Welcome to this video on solving rational equations. Let's begin. The first example is shown here. So my first question to you is, can we cross multiply? In previous problems, we had something that looked like this. A over B is equal to C over D. Then we would simply cross multiply and solve. But is that what we have here? And the answer is no. The problem is that we have two fractions subtracted from each other on one side. So we cannot cross multiply and solve. So please be careful and be aware of that. Okay? What we can do, however, is we can obtain, we can find the LCD. Actually, we're not going to obtain an LCD. What we're going to do is we're going to find and then multiply every term by the LCD in order to eliminate all fractions. Okay, most people don't like to add and subtract fractions, and by simply multiplying by a number that's large enough, we can get rid of our fractions in one step. So I will link a video that just basically explains how to find the LCD. If that's something that's unfamiliar to you and you don't remember how to do that, please go to that video and watch it and then come back to this one. Right now, I'm just going to assume that we all know how to find the LCD and then proceed from there. Okay, so in this case, we need a number that is evenly divisible by 3, evenly divisible by 6, and evenly divisible by 4. If you're like, well, where the heck did she get 3, 6, and 4? I'm just looking at my three denominators, 3, 6, and 4. Okay, so in other words, when I divide this number by 3, I still get a whole number. When I divide this number by 6, I still get a whole number. When I divide it by 4, I still get a whole number. Okay, so that number in this case is 12. Okay, 12 divided by 3 is 4, 12 divided by 6 is 2, 12 divided by 4 is 3. Okay, so in this case, the LCD is 12. Okay, again, please watch the videos that I will post that reminds you how to find an LCD if that seems confusing or unfamiliar to you. Okay, so this is my first step. I found the LCD. Okay, my second step is to multiply. Multiply everything by 12. So this is a little bit different from what we've done before. Before, what we would do is we would get everything to have the same denominator of 12. Okay, that is not what we are doing in this case, and I will show you why. Okay, so if I had an expression, if I had just something like this, for example, right, I cannot just multiply this by 12 and multiply that by 12 and call it a day, because it's an expression and not an equation, and just multiplying by 12 changes the truth value of everything. Okay, I could multiply by 12 over 12 like this. I could do something like that, but I can't just multiply everything by 12. Okay, but notice I don't have just an expression, I have an equation, right? I have an equal sign and I have something on either side of it. So because I have an equation and not just an expression, what I can do is I can go through and multiply by something that isn't just 1. Okay, so I can multiply this by 12. Okay, let me erase this so I have more room here. I can multiply this by 12. Okay, and I can multiply 3/4 by 12. Okay, and again, I can do this because I don't have an expression anymore. If this was just an expression, I couldn't do that. Also, if you want, sometimes people get confused about what's getting multiplied by 12. It's really 12 over 1. Okay, and just watch and see the magic that falls out of this. That basically in one step I'm able to completely eliminate all my fractions. Okay, so 12 divided by 3 is 4. 12 divided by 6 is 2. 12 divided by 4 is 3. Okay, so we have 4 times 2x is 8x. 5 times 2 is 10. 3 times 3 is 9. Okay, so in just these two steps, by finding the LCD and multiplying by the LCD, right, I now just have a linear equation, right? I just have a linear equation that doesn't, that's very simple to solve. Okay, so I can just solve my linear equation here. So just like, back in Algebra 1 in a previous course, we just add 10 to both sides. 8x is equal to, looks like 19. Okay, and then I just divide both sides by 8, and I will leave my answer as an improper fraction. And that's it. Okay, so again, if the LCD thing confused you, if you're lost on that, please watch those supplemental videos. Otherwise, just continue on to the next example. So let's look at this next example. So this is more typical of what you're actually going to see in this course, where you have a polynomial in the denominator, not just whole numbers. Okay, so the first thing I want to do is I want to factor this quadratic equation over here using the AC method. So I'm just going to rewrite this guy. Okay, so think about what you would want to do next, right? Maybe pause the video and jot down your thoughts and then unpause it. Okay. What we've done in the past when we were working with expressions, right? If you have an expression and not an equation, what we had to do is we had to find a common denominator. So we would do something like this where we multiply this by x plus 1 and then we multiply this by x plus 2, right? So like that, and then we would get something that looks like this: x times x plus 1 plus 1 times x plus 2 all over x plus 1 times x plus 2 equals 5 over x plus 1 times x plus 2. So from here, algebraically, I can see that the denominators are the same. So if the denominators are the same, then the numerators also have to be equal to each other. So what I could do, essentially, is multiply both sides times x plus 1 and x plus 2, essentially canceling out my denominator. Okay, so at this point, I can just isolate my focus, if I want to the numerator, and I can solve this. Okay, and then of course you would go x squared plus x plus 2 is equal to 5. We get x squared plus 2x plus 2 is equal to 5. We subtract 5 from both sides, and we get x squared plus 2x minus 3 is equal to 0. And then we can factor it, of course, like so, and we could solve it for x. Okay, so this is a valid way of doing it. This isn't exactly the way I teach. In a second, I'm going to show you the way I teach, which is just basically multiplying everything by the LCD. But if you are more comfortable with this method because it aligns more closely with previous sections, you can do this as well. Just remember, when you get to this step, as long as you have a common denominator, you can just focus on the numerator, setting the left side and the right side equal to each other and solving like I've shown you. So let's try this a different way. So what I want to do is I want to multiply by the LCD. So what is the LCD? Well, the LCD is x plus 1 times x plus 2. Okay, so we're going to multiply this guy by x plus 1 times x plus 2, x plus 1 times x plus 2, x plus 1, x plus 2. Okay, and again, the reason that I can do this algebraically is because I'm not working with an expression anymore. I am now working with an equation. So notice that the x plus 2 terms cancel out here, the x plus 1 terms cancel out here, and then of course both cancel out here. So let's see what we're left with. Well, what we're left with is that we have x times x plus 1 plus 1 times x plus 2 is equal to 5. Okay, so that's basically just the numerator of what we had before. Okay, so let's go ahead and use algebra skills to actually solve this. Okay, so we need to distribute here. So we have x squared plus x plus 2 equals 5. Okay, so we have x squared plus 2x plus 2 is equal to 5. Now remember, we are dealing with right here a quadratic equation, right? Not a linear equation. With a linear equation, we try to get all of our variables on one side and everything else on the other. Okay, when we have a quadratic equation, what we need to do is we need to get 0 on one side. And the reason we need to get 0 on one side is so that we can apply that zero product property. Okay, so we have x squared plus 2x minus 3 is equal to 0. And now, right, I have another trinomial that I can factor. So this is going to be x plus 3 times the quantity x minus 1 is equal to 0. Okay, so last but not least, I have two solutions, either x minus 3 equals 0 or x minus 1 is equal to 0. So I'm going to subtract 3 from both sides. I get either x equals negative 3 or over here I have x is equal to positive 1. Now normally I would be finished. However, you can see I pasted this list of steps here, right? We identified the LCD, we multiplied everything by the LCD, we solved for x, right? We're only halfway done. And why is that? Well, this problem has what are called excluded values. Remember, we can never divide by 0, okay? So we need to go back to our original equation, right? Which I kind of had to cover up because I ran out of space. But you can see it here on the second step, right? X plus 2, x plus 1, right? Those are the only two ways that the denominator could be 0, okay? So our excluded values, or our restricted values, come from the fact that x plus 2 can never be equal to 0, and x plus 1 can never be equal to 0, okay? In other words, our excluded values are -1 and -2, okay? So what we have to do anytime we do these sorts of problems is we have to compare our answers, which are +1 and -3, right? And we have to make sure that neither of those are going to cause any denominator to become 0. Well, I see a 1 and a -1, but that's okay, because 1 and -1 are not the same, right? And of course, -2 and -3 are not the same, okay? So it looks like both answers are valid. Neither of the values, either -3 or +1, will cause us to divide by 0, so both of these are valid answers. All right, let's do another problem. So again, we have a very similar example here. So the first thing I'm going to do is I'm going to rewrite this problem. And as I rewrite it, what I'm going to do is I'm going to factor out the polynomial on the right-hand side. Okay, so I have -5x squared divided by x plus 3 times x minus 2. Okay? All right, so now what do we want to do? We want to find the LCD. Well, the LCD is x plus 3 times x minus 2, and then we need to multiply by it. And I'm kind of out of room here, so let me do this. So I'm going to multiply this by x plus 3 times x minus 2 minus 4 over x minus 2, okay, times x plus 3 times x minus 2, x plus 3, x minus 2. Okay, so then the fun begins when we can cancel things out. Cancel, 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 cancel. Okay, so now what? Well, let's go ahead and rewrite this without the canceled terms and see what happens. Okay, so then we can use our algebra to expand and sort of make this a little bit nicer to look at. Okay, so ask yourself, do you have a linear equation or do you have a quadratic equation? Hopefully you can see you have a quadratic equation. So the strategy is not to get x all by itself on one side. The strategy is to get 0 on one side all by itself. So let's see if we can do that. So I'm adding 5x squared to both sides. So I get 6x squared minus 6x minus 12 equals 0. Remember, anytime you have a quadratic equation, you have to use the zero product property, meaning you have to get 0 on one side. Okay, so I can factor out a 6. So I'm left with x squared minus x minus 2. Okay, at this point, if you would like to, you don't have to, but if you want to, you could divide both sides by 6, right? It's still the same. So then you have x squared minus x minus 2, and now we need to factor him. So we're going to have x plus, we're going to have x minus 2 and x plus 1 equals 0. Okay, so our two solutions are either x minus 2 equals 0 or x plus 1 equals 0. So either x is equal to +2 or x equals -1. So at this point, let's visit our steps. So we've identified our LCD, we multiplied everything by LCD, and we solved for x. But again, we're only halfway through because we need to remember what are our excluded values and are any of them part of our solutions, right? So remember, our excluded values or our restricted values are generated by trying to divide by 0. So we need to look at the denominator in our equation. So the only two things we need to worry about is we need to say for sure that x plus 3 can never be equal to 0 and x minus 2 can never be equal to 0. In other words, we cannot let x be -3 and we cannot let x be +2. Okay, and we want to compare these values to our solutions. Are any of our solutions one of the restricted values? And the answer is yes. This restricted value x cannot be equal to 2 is one of our solutions. So this cannot be part of our final answer. Does that mean it's wrong? Does that mean I made a mistake? Absolutely not. Okay. Notice the way I crossed it out, you can still see all of the work. Okay. So my final answer is just this guy right here. Okay. So again, I want to see all the work. I want to see the fact that you look at the restricted or excluded values, and then you cross through that. Again, not erasing it, not scribbling it out so that it's not visible. You still want to see the work. You just want to acknowledge that because it is a restricted value, it can't be part of a solution. All right, let's do another example. Okay, so again, we're going to find the LCD. So the first thing I want to do is I want to factor x squared minus 1. That is actually a difference of squares. So that is x plus 1 times x minus 1. And that, of course, means that our LCD is x plus 1 times x minus 1. Okay, so what I want to do is I want to multiply every term in this equation by the LCD. Okay, so let's go ahead and have some fun and cross these things off. So those cancel out, these cancel out, these cancel out, that cancels out, that cancels out. So what is left? Well, we have x times x plus 1 minus 2 parentheses x minus 1 is equal to 4x squared. Okay, then we can expand everything. Okay, be careful with your signs. Negative 2 times negative 1 is going to give you a positive 2. Be careful there. Okay, and again, we once again have a quadratic, so our goal is not to get x on one side and everything else on the other. Rather, our goal is to get 0 on one side. So you can do this however you want. Personally, I think I'm going to take a minute. I'm going to combine my like terms here, like so. Okay, and then because I want a positive leading exponent or coefficient rather, I'm going to do this. I'm going to move everything to the right side. Okay, you don't have to do this, but if you do it the other way, you're going to end up with a negative 3x squared. I don't really want to mess with a negative 3x squared, so I'm not going to do that. Okay, so we have 3x squared plus 1x minus 2. So this is a bit of an annoying one because what that means is that we have to use the AC method for a greater than 1, so we can't use that nice shortcut method that we're used to being able to use. So we need to find two numbers that multiply up to negative 6 and that add up to positive 1. Okay, so it's probably going to be 3 and 2, right? 3 times 2 is 6, and then the smaller one will be negative, right, to make that, to give us a negative 6. So 3 times negative 2 is negative 6, and then, of course, 3 plus negative 2 is that positive 1. So this is the annoying part here, where we can't use that AC, we can't use the shortcut method. So what we have to do is we rewrite it as 3x squared plus 3x. If you're like, well, where the heck did that 3 come from? Well, it came from this right here. Okay. Then we have minus 2x. Again, where did that 2 come from? It came from this right here, minus 2. Okay, so then we have to factor by grouping. So we factor out a 3x, and we get x plus 1. Okay, we factor out a negative 2. Get x plus 1, and last but not least, we can factor it out as 3x minus 2 times x plus 1. So if that felt uncomfortable or unfamiliar to you when I factored that out, please just take a minute and watch the video on factoring using the AC method when a is larger than 1, and it will jog your memory. Okay, so at this point we have two possibilities, either 3x minus 2 equals 0 or x plus 1 is equal to 0. So in other words, either x equals negative 1 or 3x equals 2. So x is equal to 2/3. So at this point, you can see I'm totally and completely out of room. So I'm going to have to go to the next page, unfortunately. Pause the video if you're still copying, because I'm about to go to a blank screen. So my two solutions are either x equals -1 or x is positive 2/3. Okay, so going back to our steps here, right? We've identified our LCD. We have multiplied everything and solved for x, right? But now we have to go back and check and make sure neither of these values are going to cause us to divide by 0. So let's pop back here. Okay, so remember our two factors in the LCD. If you recall, the LCD is x minus 1 times x plus 1. So that is the expression that we have to be careful of. Okay, so in other words, x plus 1 can never be equal to 0, and x minus 1 cannot be equal to 0. So our two restricted values, of course, are -1 and +1. Okay, so this is the part where we check it. Well, hopefully you can see that x minus 1 is in fact a restricted value. Okay, so when I write my final answer, I have to omit -1 from my solution set. So the only solution to this problem is just x is equal to 2/3. Again, x equals -1 is going to cause us to divide by 0, and we cannot do that. All right, let's do one more example. So pause this video and think about what's a little bit different about this example. One thing you might notice is that this guy, he doesn't have any kind of denominator, right? If we want to give him a denominator, we could, right? We could just plop him over 1. Okay, so what is our LCD? Well, our LCD is just x minus 3, or if it makes you happy, x minus 3 times 1, right? So how are we going to fix this? Well, same way we've always fixed it. Okay, we're going to multiply everything by the LCD, which in this case, of course, as I said, is x minus 3. Okay, so I have x times x minus 3 minus 6 over x minus 3 times x minus 3 equals 2x over x minus 3 times x minus 3. Okay, so of course the magic now happens, right? We can cancel this out and cancel this out, and we're left with x squared minus 3x minus 6 equals 2x. Okay, so we again have a quadratic, so our goal is not to get x on one side and numbers on the other. Our goal is to get 0 on one side. I am going to accomplish that by subtracting 2x from both sides. Okay, so be careful with that. Make sure you don't add 2x. Make sure you subtract it. Okay, and we can use the shortcut AC method here. So we're going to have x minus 6 times x plus 1 equals 0. Again, be careful with your factoring. Make sure you always check it. Okay, so we have either x minus 6 equals 0 or x plus 1 is equal to 0. In other words, either x equals 6 or x equals -1. Okay, so again, going back to that list of steps, right? We're only halfway done. So we have identified and multiplied by the LCD and solved for x, right? Now we have to go back to the excluded values. Well, remember I covered over, but the LCD is just x minus 3. That's the only thing that could potentially go to 0. Okay, so we say that x minus 3 can never be allowed to be equal to 0. In other words, x cannot be equal to 3. Okay, when we compare that to our answers, we can see that neither answer is x equals 3, right? They are both different from that. So, since neither of these two values are restricted values, both of them are valid solutions. So you could just leave it like that. If you wanted to write it more compactly, you could, sorry, I don't know why there's a negative sign there. You could write it like that.